Welcome to Getting Started with OAuth and OpenID Connect. My name is Jakob Ideskog. I work at Curity as an identity expert. This is an 8-part series, and in this first part, Introduction to OAuth, we'll go through some of the background of OAuth. We'll go through the problem that it's trying to solve. We'll go through the actors in OAuth, and then we'll dive into the OAuth code flow, which is the most common flow and also the most complicated flow in OAuth, so it's good to get a hang of right away. And in the end, we'll also look at refreshing a token. So OAuth is pretty old by now. OAuth 1 was ratified 2010 by IETF, but had been worked on for a while before that. It was driven by Twitter and Google and others, and the main rationale was that a lot of APIs were starting to show up because of mobile gaining traction. And we needed a way to provide third-party access to these APIs. OAuth 1 was pretty clever. It relied heavily on signing, which meant the client had to sign a lot of the things it sent to the OAuth server. That also meant that it didn't require HTTPS, but could be run just on HTTP. Signing, however, is a bit complicated if you're not a crypto expert or deep into understanding these mechanisms. So that means it's pretty hard to implement clients. And that caused OAuth 1 to not gain as wide adoption as anticipated in the beginning. So OAuth 2 was worked on pretty right after OAuth 1 was released, and it was ratified 2012 by the IETF. And OAuth 2 is not backwards compatible with OAuth 1. They are very different. They solve the same thing and have the same sort of concepts, but they don't work the same way. There is no signing involved in OAuth 2, at least not from the client side. But in order to achieve this, it requires HTTPS to always be used. It's much, much easier to implement a client in OAuth 2. It's much harder to implement the server on the other end. But this has meant that the adoption of OAuth 2 has reached quite a broad audience by now. And OAuth 2 was successful already with the early spec, but since then a lot of companion specs has been written and adopted, so it's quite a large landscape now of specifications in OAuth. And this means that once you dive into it as a newbie, it's hard to know where to start. Which ones do you need? Which ones you don't need? So OAuth 2.1 is work now being started in order to pull these specs together into a new single spec that sort of defines the basics of what you're supposed to support in order to be OAuth compliant. So OAuth 2 isn't really a lot of new things. It's really OAuth 2.1, sorry, isn't a lot of new things. It's really pulling together things that already exist. So what are we trying to solve with OAuth? Well, as I said before, APIs started to show up, and we needed third-party applications to access these APIs. Twitter is a good example. Writing Twitter applications or Twitter clients was at least possible back then, and using their APIs to do so. But Twitter wasn't super happy about a third party, in that case, seeing the credentials or even the username sometimes of the user that used the app. They wanted to keep that for obvious reasons. And so we have this third party app that wants access to an API, and we have an account that is stored with the organization, perhaps, that owns the API. At least the account isn't belonging to the organization that develops the app. So this is the problem. We have an application that needs access to an API on the user's behalf, but the application shouldn't see or know anything about the user's credentials or the user perhaps at all. And the user still needs to be aware that it has allowed this application access. So this is where OAuth comes in. And to understand how to solve this problem, we need to understand what actors are involved. We have 4 actors in OAuth. And these are the names according to the specification. And it's good to know those because you'll see those here and there. So we have a resource owner who's a user, essentially. And the resource owner has some content or subscribes to some service at the resource server, the RS. That's the API. The resource owner wants to use a third-party app to reach the content. So it downloaded an app from some app store and wants to connect it to its account. So the client, which is this third-party app, needs to be delegated access by the resource owner to the resource server. And this is where the authorization server comes in, or the AS. So the authorization server delegates access then to the client. So this is the relationship between the actors. And I mentioned authorization and I mentioned delegation. So let's dive into that a bit because it's pretty important to understand. Authorization is really the task of answering the question, what are you allowed to do? And even though you might think that OAuth, open authorization, it's an authorization server, everything screams authorization about it, that's not really what happens. OAuth is a delegation protocol. So let's understand the difference here before we do anything else. What is delegation? So if my boss signs a paper and says, with this signature on this paper, I delegate you the right to go to our bank account, to the bank, and withdraw some money for the company that we can use to buy lunch. So I take that piece of paper and I go to the bank and I say, hey, my boss delegated me this right. Please let me withdraw some money. The bank looks in their registry and says, nah, we don't have any records of your boss being allowed to delegate you any access. That needs to be predefined with our bank. So we're not going to give you access. We're not going to give you any money here, even though you have a signed piece of paper. Your boss delegated you that, right? But we don't want you to. We don't have that in our record, so you're not going to get the money. So what happened here was my boss delegated me access, but the bank authorized that access. So it looked at that delegation and said, true, it could be valid, but it doesn't match our conditions for releasing any money for you. So the authorization happens when we take all the parameters into account and make a yes or no decision. Should you not be allowed to do this? So that's the difference between delegation and authorization. So OAuth is really a delegation protocol. We delegate access. The authorization server, despite its name, provides tokens that are delegations, so to speak, that you can use to gain access. But the API will at the end decide, even though you have this right, this token, are you allowed to do this operation or not? That comes in the end. So let's go into the flows. The OAuth code flow. This is defined in the base specification, and it's the most common flow. It's the most flexible flow. You can use it for a lot of things. And it's very good to understand in the beginning when starting with OAuth. It's running in two stages. Stage 1 happens in the browser, and stage 2 happens in the backend. So we have our actors. We have a client, and in this case, the client is a web application. So it's a web page with a backend. And it's important that it has a backend in this case, because that means in OAuth lingo, it's a confidential client. It can keep a secret. We can have clients that only are front-end clients, like single-page applications. We call them public clients because they cannot keep a secret. Anything you put in JavaScript, anyone can read. So in this example, we use a confidential client. You can use the code flow for public clients as well, but you need to apply other security measures in order to keep it secure. And we'll go through that in later parts of this series. So let's start. The authorization server, it exposes two endpoints to begin with, the authorize endpoint and the token endpoint. And these paths /authorize/tokens, they're not predefined. They can be anything, but conceptually, we have two endpoints. So the first thing that happens, the resource owner visits the client and clicks login. The client now needs to get this access. So it redirects over, it does a get. So it changes the address bar of the browser and moves the user to the authorized endpoint of the authorization server. And when it does that, it passes on some parameters on the query string. First of all, response type equals code. This tells the authorization endpoint, I'm going to toggle into code flow mode. So I'm going to run the OAuth code flow. The response type, you can think of it as a toggle for what mode the authorized endpoint runs in. We'll see later that we can run other flows on the authorized endpoint. It also passes the client ID. So each client is pre-registered with the authorization server with a known ID. And in this case, my app is the ID. So I tell the authorized endpoint, hey, I'm my app. I also pass in something called scope. This is optional, but I can tell the authorization server I need read access now to the APIs. The scope is just a space-separated string, so it can be anything. So it could be Zort-to-Zort access. You make it up. And then later we also pass in state, my random state. This is an identifier that the client may use, it's optional, to send in, and later it will get it back on the callback, as you'll see. So it's a way for the client to keep track of what did I start when it comes back. Okay, so this is the basic parameters of the code flow. The OAuth spec, however, says authentication is beyond the scope of this specification. So the authorization server actually has no idea how to authenticate the user. That's not part of the spec. So, but in order to do anything, the first thing it needs to know is who is this user? We need an authenticated user in order to do this. So a common way is to redirect over to an authentication service in the middle. Some implementations of OAuth, they do implement the authentication directly in the OAuth server. That's not really recommended. It's recommended that you separate these for architectural reasons. So an authentication service running next to it, which only has the responsibility of figuring out who is the user. And in this case, the authentication service now needs to verify the user's identity, and maybe it just shows a username password field directly in the browser, or it tells the user to open an app and authenticate, or any means that it needs to take to authenticate the user. And when it's done, it redirects back to the authorized endpoint, and the authorized endpoint then knows, okay, this is the user. Now I'm going to check, okay, yeah, this client asked for read scope, that's okay, and I know who the user is, everything's fine. I'll issue a one-time code called an authorization code, and I'll put that in the query string now of a redirect. So the authorized endpoint will redirect back to the client to a predefined callback. So I said before, the client is registered with the authorization server, and one of the things that the authorization server knows is what's the redirect URI of this client. So it will redirect back to a callback endpoint of the client. It passes the code, and it also passes the state if that was sent in the beginning. So this is where the client will now know, oh, okay, this is the request I started here 5 minutes ago or 30 seconds ago. Now we can leave the browser. That's the first part. We've done our browser part of the code flow. So now let's move to the second phase of the code flow. The client takes the code and makes a back channel request to the token endpoint, the second endpoint of OAuth. The token endpoint is not a web endpoint. It's not supposed to be accessed from the browser like the authorize and show things to the user. It's an authenticated endpoint where the client, first of all, needs to authenticate itself, and it needs to do this on a back channel. So you always post, and you always use application www form URL encoded content type. And like the authorize endpoint where we toggle with the response type, here we toggle with something called the grant type. We say we're going to do the authorization code flow part 2 by sending grant type equals authorization code. And I'm client my app, But now it's not enough just to say I'm client my app. I also need to pass in a secret or some way of authenticating the client. So a secret is common and easy to understand. So that's why I have it here. So you send in client underscore secret equals something. You can also pass it as a basic authentication header in the authorize header. And finally, we pass the code. Code equals whatever we received. So the code, I said it's a one-time code. It's called a nonce, not more than once. It's usually very short-lived, typically in the range of 5 to 30 seconds. So you don't have a lot of time here. And it's bound to two things. It's bound to the client ID, my app, and it's bound to the user's identity because the user logged in before. So we stored that in the code. So now in order to redeem this code, we need to authenticate the client like this, and we need to pass in the code. So the authorization server checks, is this a valid code? Has it been used before? Have I seen it before? No? Okay, fine. And then it issues the tokens. There's two tokens in OAuth, the access token and the refresh token. The access token is the one we send to the API later on, or the resource server, in order to get something or do something. And the refresh token we can use in order to get more tokens. So the access token here could be of any format. We'll go through that in later parts of this series, the various token formats. It could be a random string, it could be a JSON web token, or whatever. It also tells us in this response the scope, what was issued. I requested the read scope, but it's not necessarily so that's what I got. Maybe the authorization server decided something else. So it will tell us, what scope did you get? And it will also tell us how long is this access token valid for. So expires in is for the access token. It expires in 300 seconds, 5 minutes. Refresh token, as I said, we can use to get more tokens. We don't see here how long the refresh token is valid for. That's not part of the response. That's typically a documentation issue. With when you set up your client, you usually read in the docs how long is the refresh token valid for, or you just use it until it's access denied and then you have to log the user in again. Normal lifetimes for a refresh token could be between an hour and infinity. It's usually long-lived. So I have the tokens. I can use the access token now to call the API and do the operations I intend to do, and I store the refresh token for later use. Okay, so let's look at the flow, how it works. I'm going to use OAuth.tools. If you haven't used that before, I definitely recommend it. It's an OAuth playground or place where you can learn and try out OAuth flows against an OAuth server. So we're going to start a code flow. And I've set up an environment, which essentially is an OAuth server or an OpenID Connect provider. And I've configured it to use my Curity instance. And I've set up all the endpoints using metadata, which we'll go through in the later part of this series. So it knows how to communicate with the server now. I've also configured a client, my app, with a secret and marked that it can do a code flow. One important thing here, OAuth.tools, like any client, if you run the code flow, it has a redirect URL. So I've configured my client now to use this redirect URL. So if we take a look at that client, we can see that in the OAuth server, that redirect URL is now whitelisted. That's very important because that's how we redirect back the code, like I explained earlier. But that is also the contract, so we know we're handing it off to the right party in the web flow. So whitelisting of redirect URIs always occurs. So this one puts it here. So if you use an OAuth server, copy this and put it in there. So then let's configure it. Let's use that client that I had configured, and let's request the read scope. So now I can start the flow. And here we can see the start URL. So this is the URL. If you would click a login button on a website, it would redirect to a URL like this, to the OAuth server's authorized endpoint, and with the client ID, a state. In this case, OAuth tools needs a state to know where to go back to, so that's how it uses the state. The scope that we request, the response type being code, we're doing the code flow, and optionally you can send a redirect URI. And that is because if you configure more than one redirect URI in the OAuth server, which is okay, we need to tell the server which one are we intending to use here. So I'll click run. I get prompted to log in. And now we can see I'm at the OAuth server, but not the authorized endpoint. I'm currently now on the authentication service like we discussed. So I'll click login and I'm redirected back. And here in the end, we can see we got a code. This is the authorization code. So now we just need to post this, and we can preview the post command here and see, okay, we're going to the token endpoint. We're sending in basic authentication now, client ID and secret. And we're passing in the authorization code, grant type, the redirect URI needs to be sent if you sent it in the first request, and we're passing in the code here. So let's click redeem. And now we can see we got two tokens. We got an access token and we got a refresh token. And in OAuth tools, you can view this, the inners of these, if your server supports introspection. So we can see what the subject was, who the user was, and this is a pseudonym in this case, so I don't really see the actual user, which can be useful sometimes. We can also see that this is an access token, who issued it, we can see the expiration of it, so on. So this is a pretty bare minimum token. In later parts of this series, we'll go through how to shape these tokens to contain more claims so that your API can take better decisions. So let's try this again, but let's do it manually. So I'll copy the start URL and I'll paste it in. So imagine I click the link now. So I'm going to use a different app which has a different redirect URI, so we don't end up at OAuth tools. And I'm going to start the flow. Now I don't need to log in because I just did so I'll be single sign-on at the OAuth server, so we'll just see it blink. Now I hit localhost 8000, which was the redirect URI, and there was nothing there, but I can see on the query string that I have the code. So let's take that. Remember, the time you have here, the code is a short-lived code, so it's usually 30 seconds or less. So if you're doing things manually, you may have to be a bit fast. So in Postman, I've set up a post now to the token endpoint of my OAuth server. My client ID and secret, this time in the post body, so you see it. And grant type, authorization code, and the code. So let's see if I did this in time. I didn't. So more than 30 seconds took place here. So I just need to run this again. So simply take the URL and not talk so much this time. Paste it in, but I'm going to use app2. Try again. Got another code. And I'm going to run that, post it, and here we see this is the response from the OAuth server. 200 OK, and here's my access token, and here's my refresh token. All right, so time for refresh. So like I said before, we got two tokens from the token endpoint, a refresh token and an access token. And the reason is the access token is short-lived. Usually in the range of 5 to 30 minutes. It's not really recommended to have it long-lived. And in later episodes, we'll go through a bit on why. But in short, it's a bearer token. So if you drop it, someone else can pick it up and use it. So we don't want it to live for too long. So instead, we provide a refresh token. And the refresh token is there so we don't have to run the whole code flow just because 5 minutes passed. The user will get really annoyed. So what we can do when the access token expires is we can send the refresh token to the token endpoint. Just like before, we need to send in our client ID and a client secret or some other client authentication method. And instead of authorization code as the grant type, now we say refresh token is the grant type. So we toggle the token endpoint and say we're not doing the code flow now, we're doing the refresh flow. And the refresh token is also passed in as the parameter refresh token equals something. And now the authorization server can check, is this refresh token matching that client ID, and is it still valid, etc., etc. If so, it will simply respond with a new pair, new access token and a new refresh token. It will also tell us again what scopes, how long is the access token valid for. It may have reduced the scope of the access token. That's allowed to do over time. And usually you don't allow reuse of refresh tokens. They're used once only. But it's allowed to configure an authorization server to reuse refresh tokens so that you use the same one every time. However, from a security perspective, it's recommended to always issue new refresh tokens and revoke the old one as soon as it's used. So now we have new tokens and we can continue to access the API. So if you think of this in a normal application context, like a mobile application, what typically happens is the first time you open that application, you logged in and you got these tokens in the app. The refresh token was stored in some secure storage. And later when you start that app the next time, or when you come back to that website, it finds that refresh token and will do a refresh, and then it can continue to talk to the API on your behalf. So they can live for a very long time as long as the client can keep them secret and keep them secure. Okay, so we ran the code flow last time. I'm just going to run it again real quick so we have a fresh token. So I'm going to run the code flow and in the end redeem the code, and now we have tokens, new tokens. So let's start a refresh flow. So we have that here on refresh tokens. We've got a new flow here on the side. So I'm going to use the same client ID that I used to get the tokens the first time. And that's it. But I need a token as well. So if I click down here, I can see that, oh, I have a refresh token in my other collection. So that's what I'm going to pass in. So now we can see once again the post command here. What will it be? Well, post to the token endpoint, authenticate the client, URL encoded, and now the grant type is different. So we have grant type refresh token over here, not authorization code like in the other flow. And we pass in the other parameter, which is refresh token. So I'm going to click refresh, and I got new tokens. So if we do the same thing in Postman, but with the other client, we just used app2 here to get a token. So I'll take that refresh token now, and we can look at a refresh token post from Postman. So I'll go to the token endpoint. I'll put my client ID, my secret, either here or in basic auth. The grant type is now refresh token, and then the parameter refresh token should contain the value of that refresh token. That's it. So click send, and I got a new access token and a new refresh token. Once again, expires in here always denotes the expiration of the access token. The refresh token lifetime, you have to read the docs or it's communicated out of band. So that's not responded by the standard in the server. But if I try this again, like I mentioned before, a refresh token can be configured to be once only or reuse. And the standard setting in Curity is that it's once only, and that's probably common in most OAuth servers because of the risk it entails to be able to reuse a refresh token. So I'll click send again, and I get invalid grant, which is a standard OAuth error. It's a bad request, and it says invalid or unknown refresh token provided. So I cannot refresh more than once. So if I drop it on the floor or do something like drop the response, or so, then I simply have to start a new code flow if I lose this refresh token in some way, or fail to refresh, fail to read the reply, for instance, if the sockets get cut in the middle. So that's good to know about refresh tokens. They're once only usage.
Thank you for listening. That's all for this time. Visit curity.io for more information or developer.curity.io for resources and how to download the server. In the next part, we'll go through OpenID Connect and how it relates to OAuth. So tune in on that. Thank you for listening.